there's two circumstances that could happen depending on our compiler. Right? One thing is this could equal, what I say, like 58.5, or this could now equal to 58.0. So one of those two things is going to happen. One of those things is what we want. One of those things is not quite what we want. So why might this second one happen? Well, again, we are still, right, doing math with two separate data types. And depending on what these two separate data types are and how these two separate data types are, or the version of the compiler we have, it's going to do one of two things, right? I'm not going to care. However, you will not be able to do it in PG2, so it's kind of better just to get it happen. Is we could say, okay, we have integer equal sign matches operands. A is really storing an integer value of 5, right? Or 65. We already know that. Boolean is also storing an integer value. Boolean, the way it works is if it is 0, then that is considered false. But if it is any other number, that is considered true. Floating point numbers are actually using scientific notation. So this is going to be 5 plus 5 times later. And you would continue doing that, right? If you guys are aware of scientific notation, 5 times 5 times 10. So it's doing scientific notation here, but it's only using whole number values. This is the same thing too in this particular one. This is going to be 5 plus 5. Okay. So, using our Pokemon as an example, right? Everything in Pokemon has, like all the stats in Pokemon have whole number values as their thing, right? Like, if Pokemon has an attack of 65, right? Pokemon has an attack of 65. However, somebody uses Tail Swipe, right? Which is going to reduce their attack by a percentage, right? So it's going to be like minus 10% of 65, right? So how do we do that? How do we actually minus 10% from this? More than one equal sign matches operands. Again, just where I would need to see more context of that, because it sounds like there's more going on in that code. But it sounds like you don't have that. You don't have to set up in a way that's similar to this. Okay. So how do we do attack times 65? Or sorry, 65 times 10%. You may think that it's something like, okay, we're going to do this times, 0.10. But this is going to give us some issues. Because what's actually going to end up happening here is these are two different data types. And the computer's going to do its best to figure it out. But at the end of the day, it might not look what we expect it to. In this particular circumstance, if we had a variable that was int attack is equal to 65, and then we did attack is equal to attack times 0.1, if we wanted to only give it, if we wanted to do 90%, we would do that, right? 0.9. So if we wanted to reduce the attack by 10%, it would look like that. What do you think is going to be stored in attack? A whole number. So if we go to our calculator, right? We come here, we do 65 times 0.9. Nope. 65 times 0.9. Do not know how to use calculator. 65 times 0. I'm using a programming calculator, so it can only do whole numbers. That'll do it. Okay, 65 times 0.9 equal to, I am not good at this. 0.9 is going to be equal to 58.5. So, I ask you again, if I do attack times 0.9, what's going to be stored in attack? 58? Any other guesses? The answer is 58. It's going to drop off the decimal point, and it is going to store 58 in there. Which honestly is probably fine. For Pokemon, that's probably fine. And this is actually what Pokemon does, because Pokemon's written like C, I believe, but it might be written in assembly. And they don't have fractions or percentages at all. And when we later on in the class, we'll look at the actual damage calculation of Pokemon, and you'll see they jump through a lot of hoops to avoid having to use a fraction. But yeah, we're not going to be able to get that. But what if I actually do want to use the real value of attack as, as a percentage, right? If I want that decimal point, right? Well, one thing we could try, right, is we could say, okay, we have int attack. This out real quick. We have int attack. We want to say like new attack, right? And we'll make this a float. So I'll make this a float, and then we'll say new attack is equal to attack times 0.9, right? So new attack equals 0.9. This might work. I don't think to run this, so I'm not going to know exactly if it would. So, but there's two circumstances that could happen depending on our compiler, right? One thing is this could equal, what I say, like 58.5, or this could now equal to 58.0. So one of those two things is going to happen. One of those things is what we want. One of those things is not quite what we want. So why might this second one happen? Well, again, we are still, right, doing math with two separate data types. And depending on what these two separate data types are and how these two separate data types are, or the compiler we have, it's going to do one of two things, right? And that is, it's either going to convert the attack to a float, or it's going to convert the float into an integer. It's a little bit unpredictable, right? So remember how I said early on in the class that we don't want to leave things up to chance, right? We don't want things to happen automatically if we can avoid it. We want to be able to understand exactly what's going in our code at all times. What's going on right now is known as an implicit conversion. We talked about this a little bit earlier, right? So an implicit conversion means it's trying to do something automatically based on its best guess. I don't have anything to run this, so I'm not going to know exactly if it would. So, but there's two circumstances that could happen depending on our compiler, right? One thing is this could equal, what I say, like 58.5, or this could now equal to 58.0. So one of those two things is going to happen. One of those things is what we want. One of those things is not quite what we want. So why might this second one happen? Well, again, we are still, right, doing math with two separate data types. depending on what these two separate data types are and how these two separate data types are the first the compile we have. It's going to do one of two things, right? And that is, it's either going to convert the attack to a float, or it's going to convert the float into an integer. It's a little bit unpredictable, right? So remember how I said early on in the class that we don't want to leave things up to chance, right? We don't want things to happen automatically if we can avoid it. We want to be able to understand exactly what's going in our code at all times. What's going on right now is known as an implicit conversion. equal to attack, right, it's going to perform an implicit conversion. I mean, it's going to automatically try its best to figure out what we're trying to do, and it's probably going to end up at 65.0, right? That is a predictable outcome for something that is happening automatically, right? This is going to try to do the same thing, but the outcome is a little bit less predictable, right? So while implicit conversions are nice and cool and a bit of a quality of life feature, we should avoid them because we don't know what's going to happen necessarily, and it's unclear looking at our code what exactly is going on. Does that make sense? Like, if we remove the idea of this compiler has these cool features that allows this implicit conversion to work, you could look at this code in isolation and say something's wrong here, right? Because we're trying to assign a float, an int to a float, which is going to be not going to work. So what do we do instead? When we can't use an implicit conversion, what do we do instead? Well, does anybody know the opposite of the antonym, the opposite of implicit? Somebody said it, I heard it. Yeah. The opposite of implicit is explicit. That means we are doing it with intention. We are not allowing it to just work on its own. We say specifically what we want to happen. And that, can you do an STD? So when we're dealing with two similar types, two types that are similar enough, right, where there's a predictable what do we do instead? Well, does anybody know the opposite of the antonym, the opposite of implicit? Somebody said it, I heard it. Yeah. The opposite of implicit is explicit. That means we are doing it with intention. We are not allowing it to just work on its own. We say specifically what we want. To happen. And that way we know exactly what's going to happen. Right? So when we're dealing with two similar types, two types that are similar enough, right, where there's a predictable path from point A to point B, we can perform an explicit conversion by doing what's known as a cast, right? So here's how I like to remember this. The way that a cast works is it tries to find the shortest distance between two things. And these things are generally going to have to be compatible. So let's say we have two buckets. I have a bucket, and I have another bucket. This bucket contains 1 gallon of water, right? We can talk about the bite size of what these variables can hold, but it's not really important. If it can hold a larger value, then easy, we can take 1 gallon of water and pour it. This is the equivalent of a implicit conversion. This is, it says, I can see a very clear path, no friction at all. We can try to go from point A to point B. That's easy. However, when we flip the scenario around, when we say, okay, now we have a 5-gallon bucket of water, and we would like to pour the 5-gallon bucket of water into a 1-gallon bucket. There's a fairly clear path, but there is an issue here, right? Number one, right? If we're going to pour a 5-gallon bucket of water into a 1-gallon bucket of water, we're going to lose some water, right? There's going to be some data loss. That much is clear. But number two, we are going to need some kind of actual magic. There's going to need to be magic happening here, and we don't want to have that magic happen on its own. We want to explicitly perform magic. Does anybody know how to explicitly perform magic? There's a word for that. If I'm in Harry Potter, and I'm explicitly using a magic spell, what am I doing? I'm declaring a spell? I am casting a spell. And that is how we're going to do this. We are going to do an explicit conversion using magic through a cast. So there we go. So, this is what a cast looks like. So to perform a cast, all we need to do is between the data that we are trying to convert and the assignment operator, we need to convert it first. So you can read it from right to left. We're going to take this, convert it to this, store it in here, right? So we must put the data type that we are trying to convert to inside of parentheses, right? And that will convert this to that. So that means here, right, what we can do is we can say, use attack here as a float. So use attack as a float, multiply it to this, store it this, now we predictably, all the time, get that result. Now, if we wanted to be even more explicit than this, or if we wanted to make this a little bit easier to read, right? What we can also do is we can use parentheses for order of operations. So we can say a separate set of parentheses like this. So this will perform order of operations, convert this to this, multiply by this, store it there. Is this necessary? Probably not. It doesn't make it a little bit easier to read. Yeah, depending, right? It makes it easier to read for me. If it doesn't make it easier to read for you, then don't do that. But that is the idea here. So this is performing an explicit conversion using a cast. Anybody have any questions about this? All right. So next up, there's another type of explicit conversion that's pretty common, right? This explicit conversion is known as parsing. Parsing, the word parsing means to dig through something and try to identify something inside of it. So to dig through something and try to find something inside of it, right? Or like parsing data, right? We're like looking through the data, breaking it apart, trying to find something specific in it. We commonly use parsing to break up large chunks of data that are typically represented as strings. And we are going to use parsing here to identify some specific things in strings, specifically numbers. So, you guys have mostly, hopefully, looked at or completed lab 1. And during lab 1, you are asked to capture the user's age as a string. Because when we capture stuff from the console, we capture them as a string. However, what if we wanted to perform some type of math with their age, right? What if we wanted to say, okay, SDE, cout, age, and then we wanted to say, get line, well, let me get age here. You say SDE string, age is equal to string. Then if you get line, SDE, cin, age, store that, and then I want to say SDE, cout, you are about, and then we'll say plus age times 365, 8 laptop keyboards, plus space, days old, right? This would break. This would break because I'm trying to concatenate, it would break here, is where it would break. Because I'm trying to multiply an age, which is a string. So I cannot perform math on a string. What I need to do is I need to take the age string, search through it for a compatible number, and pull that number out. So you're going to do that by using one of the available parsing methods. Now, what I can do here, in this particular circumstance, between here and here, right, is I can make a new variable that's an integer called number age or something like that. Age number convert age from a string to int. The way I'm going to do that is I'm going to call a method in my standard template library, because anytime we're using a string, you can probably assume that we need the standard template library, right? Strings are part of the standard template library. We don't have access to strings without the standard template library. So anytime we're doing anything string related, generally needs the standard template library. So we're going to do std, and then we're going to do s2i. And then inside of parentheses, we're going to pass this. So it's just like getLine, where we pass these guys into parentheses. But here, inside of parentheses, we're going to pass age. Does anybody want to take a guess of what s2i is? Exactly correct. So s2i means string to integer. This is a method that takes in a string value, parses through it, tries to identify a compatible integer, and if it does, results in a compatible integer. So by setting std s2i age equal to age number, we will preferably, presumably, get the age 65 out as an integer. Does that make sense? Now, there are a number of parsing methods available to us. S2i is just one of them. Let's say I instead wanted to have this be a double. Does anybody want to take a guess on what method I would use here? Yeah. That is correct. There's S2i. We also have S2f, which would be string to float. There's going to be a number of these different methods that you guys will have to use for your lab 2. When I ask you to use these in your lab 2, I'm not going to make you guess or look it up. I'm just going to tell you which method to use. I'm going to give you a value as a string. You are going to return it as a float, or 2i. Exactly correct. So 2i means string to integer. This is a method that takes in a string value, parses through it, tries to identify a compatible integer, and if it does, results in a compatible integer. So by setting std s2i age equal to age number, we will preferably, presumably, get the age 65 out as an integer. Does that make sense? Now, there are a number of parsing methods available to us. S2i is just one of them. Let's say I instead wanted to have this be a double. Does anybody want to take a guess on what method I would use here? Yeah. That is correct. This S2d. We also have S2f, which would be string to float. of these different methods that you guys will have to use for your lab 2. When I ask you to use these in your lab 2, I'm not going to like make you guess or look it up. I'm just going to tell you which method to use. I'm going to give you a value as a string. You are going to return it as a float, or an integer, or a double, or a long. Anybody have any questions about this so far? Alrighty. So we are at about 3:05. We're going to take our second break. We're actually at 3:20. And then from here, we're going to go into our programming demonstration. And then we'll probably stay on our programming demonstration for the majority of the rest of the class. So we'll just program Pokemon related things probably up until we're done. Go over labs like that. Now before we do that, does anybody have any questions about this? Yes? This would still crash. Would this crash if it wasn't a number? Yes. So if it got through the whole thing, if it got through the whole string and it could not find a compatible number, it would result in an error. Now, there are two different types of errors we can run into in programming. One is known as the syntax error, which breaks everything, but runtime errors, such as this would make a runtime error, would crash in a way that's expected. So it would do what's known as an exception, right? So exceptions can be handled. So even if this didn't crash, result in an error, we could say, we know that's going to happen and we can handle it from there. We're not going to do that in this class, but it would crash in a way that makes sense and is understandable, right? Yes. You're not going to be able to use them until 3 or or 4 classes from now, basically. The reason being, the way it's set up is we are going to send you stuff that shouldn't break. So anytime it does break, it's your fault. Alright? So, that's just the simplified stuff. Alright, so, at this point, you guys should understand a handful of things. Right? Number one, primitive data types. Right? These are our primitive data types. We can include string in here because it's basically primitive data type. Number two, conversions. We have implicit conversions, which I would recommend against, and explicit conversions, both through casts, right, and parsing. Casts require you to put the data type that you are converting to in parentheses between the value and the assignment operator. And parsing is going to happen by using one of our numerical parsing methods, of which are pretty predictable. Any questions? Yeah. Yes. That is also counting negatives, yes. Now the reason that is because of a very technical thing, but it's not that big of a deal. Usually I explain it in the slides. All of these have binary values, right? So basically everything that we have is being stored in a series of bits, and these bits have binary values. A binary value is either going to be on or off, right? You can look at it as on and off. You can also think about it as 0 and 1. 0 and 1 being binary values, right? Just so we're here, a combination of 8 bits, this is 8 binary 1 or 0 values, is known as a nibble, right? So 4 bits is a nibble. Did anybody know if you forget programming, what does a nibble mean? Like, what is a nibble of something? What is a nibble? A nibble is typically referring to a small byte. So 2 nibbles, or 8 bits, is 1 byte. So a nibble is literally a small byte here, right? When we're talking about integer values, but also for whatever reason in C++, Boolean values. The C++ is one of the only languages that does it like this. They are represented in 4 and 8 bytes, right? So the only time you ever see a false value is if every single byte is 0. So if every single byte is 0, then it's false. If any byte is a 1, then it's considered true. Now, one of these will be 1 if it's a negative number, because by default, a integer can go from about -2 million to +2 million. Don't quote me on that, but it does that. It includes the entire range, right? So 0's in the middle, so this is like 0's across the board, but either one of these would result in one of the things being 1. Int is 8 bytes. Or, yeah, it's 8 bytes, 8 bits. I think it's 8 bytes. It's 1, yes, it's 8 bytes. Sorry. Well, there's a whole slide. It depends. There's different ints. You have to define in C++, you have to define an int 32 to get a 32-bit. So, by default, it's 4 bytes. There you go. And then we have, oh, you're not seeing it. So by default, it's 4 bytes. All these guys are 4 bytes. And then we have, oh, why does it do this? And then we have our chars are going to be also, chars might be 8 bytes off the from the get-go. They're 1 byte. And then strings are whatever multiples of this. Now, that's an important distinction because you know programming, but you don't know C++. C++ is weird. That means that, like, if I were to try to do some things in strings that I would normally try to do, right, like certain special characters, you cannot do them in a standard string. You have to say, like, a long string or a 64-bit string. So it gets real weird. That's why I don't teach this stuff, because it's a lot, right? But yeah. But yes, there's a lot of other different types. C++ is very memory specific. It tries to be as boiled down and like efficient as possible, but as a result, it means it's like driving a car. It's like driving a car on manual versus driving a car on automatic, right? A lot of things have to happen yourself, so just keep that in mind. Can you do an STD by itself? You could use so just as an example, right? This right here is resulting, it should result in a double value, right? So when I do this, assuming it doesn't crash, it should result in a value that is a double, right? We got that so far? Everybody understand what I mean by that? So let's just scroll down a little bit, right? If I have double number is equal to 0.65, we'll say, right? And I say double by itself, number by itself, right? 0.65, or STD S to D 0.65. These are all the same. There is no difference between any of these, right? So anywhere that I could use 0.65, I could also use the variable identifier number because it contains a value of 0.65. But also, anywhere I could use 0.65 or number, I could also use STD or S2D, so string 2 double 0.65. There's no distinction between these. A double is a double is a double. So anywhere we're expecting to see a double, I can provide a double by any means. And that'll make more sense when we talk a little bit more on Friday about methods themselves. Because methods, that's what this is, you will have to tell, when you make a method, you will need to tell the compiler what that method will result in. Does it result in a string? Does it result in a float? Does it result in a double? Same way as like when we define a variable, we need to define a type. We need to define a type for the method as well. And then anywhere that we would otherwise use a string or an int or a double, we could use a method that was defined with that type. Just same thing for a variable. Does that make sense? That's a little bit of a preview for later on, but so STD by itself is just a double result. Alright. So now we're actually at 3:15, so we're going to come back at 3:30. So we're going to take our second break. I'll see you guys back. Here we go. So we are back into our day one Pokemans. We don't have a lot of stuff here. We didn't get very far on Monday. But now we're going to take this opportunity to kind of to build on this a little bit more and try to flesh it out. So before I get into kind of the stuff that we did today, I want to clean up this code to make it a little bit more reusable, and also to make it a little bit more Pokemon-y. So this is going to be some specific stuff specifically for this demonstration that does not necessarily correlate directly with your assignments, unless you're doing the challenges. The first one is that when I run this right now, right, it doesn't look very cool. And I want it to look cool. Looking cool is very important to making a video game of any type, usually anyway. So I'm going to make one of those boxes. In C#, I could have made a super cool looking pretty box. In C++, it's too hard, so I'm just going to make a very standard box. And I'm going to do that by seeing out a lot of equal signs. This is a lot of equal signs, even though it looks like one big equal sign. That's just my font. It just does that. But we're just going to see out a lot of equal signs. I'm then going to use a new line to start writing on the next line, and then I'm going to end the line. So we're going to skip 2 lines here. And that's a stylistic choice. That is I just want it to look like that. And then I'm going to copy and paste this line here. Now, one thing you should be aware of. Anytime that you find yourself copying and pasting your code, it's probably a better way to do it. The thing we'll talk about on Friday called drive, don't repeat yourself. If I'm copying and pasting my code, then it's probably a better way to do it. And the better way to do it here is to take this whole value, right? This is a full string value, nobody does that crap, double quotes, and store it in a variable. So I'm going to come up here. String divider is equal to, and I'm just going to take all of this, I'm going to cut it, that's Control X, for you guys that aren't familiar with cutting, Control X to remove it, and then paste it here. And then down here, instead of doing that, we're just going to say divider. There we go. And we're going to say, what's your name? I am going to put a new line after this. I don't know if I really want it there, but we're going to find out. We'll see when we do it. And then we're going to do this. Divider. Now, one thing that you guys need to do as part of your lab 1 that I didn't get a chance to get to in your in this demonstration is std cin.get. So what cin.get will do is cin.get will pause the console, but it doesn't consume the input, which means it's not really waiting for you to type anything in. It doesn't take anything in, it doesn't do anything with it. It just still pauses the console, right? And that's going to be important because before we go to the name prompt, I do want to pause here. I'm going to change this line of code in a minute, but I'm setting myself up with some tools that I know I'm going to use in the future. So we're going to do std cout, and we're going to say new line to create two new lines here, maybe. I think that'll work. Maybe one new line. And we're going to say press enter to continue. ... And what we should see is press enter to continue, and then it should pause, and then it'll prompt the user. So let's see how that goes. Let's run it. Okay, so now we see, hello, what is your name? We're paused, we're stopped, and it says press enter to continue. And now when I press enter, now I get the prompt, and I say Doug, and it says welcome Doug. So that's cool. That first little bit, like here's a box, that's kind of Pokemon-ish. That's good, that's looking good. But then it just writes everything under it, which is not as Pokemon-ish, right? In Pokemon, what we see is like a message box on the bottom, and it fills the box, and then we press enter, and it like scrolls it a little bit, and then it like clears the box, and it shows stuff in it again, right? That's how Pokemon works. So we can mimic that here. We can do something that mimics that here, and the way we do that is we clear the console. So there's a few different ways to do this. I'm going to do the Windows specific way because that's the easiest way, and that is to call system and pass in CLS. That would clear the console. So that's good. So then we will do a clear here, right? Because this is like the end of the first box. So this is like end of first screen. We're going to go here, and then this is end of the second screen, right? So at the end of the screen, or at the beginning of every screen before we show another screen, we're going to clear. And also, I probably want this formatted in that box. So I'm just going to grab all of this, copy, paste that down here, and instead of doing that, we're going to do this. So I'm just going to take this string, replace that string. Except I need to remove. All right. So now we got 32 lines of code. So we're getting pretty chunky here. But I'm missing the divider. So I need all of this stuff as well. So all that looks good. And this will be the end of our third screen, right? So those are all of my lines of code. So we should see. So the way I like to lay my code out here is similar to how it's going to display in the console. So I'm going to see hello, I'm going to see divider, space, hello, space, divider, 2 lines, then that, right? So this helps me visualize what I think that's going to look like. I also don't like my words being flush up against the side of the window, so I am going to put 2 spaces here of padding. I think this is going to look good. So let's run. So, hello, what is your name? Type in my name. Welcome, done. So now, we have what appears to be a series of 3 separate screens. That's good. So, we did some coding here. So it looks good. Let's put in some breakpoints and see how these breakpoints work. So the first thing I'm going to do is I'm going to put a breakpoint right here. The next thing I'm going to do is I'm going to put a breakpoint right here, probably after this. So right here. Last thing I'm going to do is I'm going to put a breakpoint down here. Actually, let's put a breakpoint here as well. All right. So let's run it right off the bat and see what we get. So right now, I'm running a breakpoint on line 6, which is the first line of my main method. And remember, it stops at the beginning of the line. So it doesn't go all the way through the line. And we see the only thing we currently have available right now is a variable called name, and the value is an error reading characters of the string. The reason we are receiving this error is because we stopped at the beginning of the line. So we don't know the value of the string. If I use the step into button up here, which also works with F11, I can step further into the line, and it goes and executes this line and then stops here. So now we can see the value of name is pink because the value of name has changed to an empty string, but we don't have the value of divider yet. Divider now has a value of nothing. If I step into this again, you can see we're now in the next line of code, even though there's no breakpoint there. And both name and divider have values. So at this point, at line 9 of my application, right here, which is where we are, this is the state of my application. I have two variables available. One is equal to an empty string. One is equal to a bunch of equal signs. There is nothing in my console yet because I have not rerun a line. Even though we're here, we have not run that line of anything being written to the console. Now, if I press continue, it'll run all of this code until the next breakpoint, which is here. Which means we should see all of that code. We see all of this. It actually paused it at cn.get. So this hasn't gotten to that code yet. So we come here, press enter, then we hit that breakpoint. So now we are here before the name prompt is posted, right? But after the system has cleared the console. So we see cleared out console. This is where we are. So now we'll run it again. Let's step into it. So now we step into it. We currently have access to name. Name is empty. If we step into this though, no, we're going to get prompted. So we're going to get prompted right now. So we are in the prompt. So we stepped into that, so we get to the prompt. Let's say Doug. Now, we see name has changed to Doug with lowercase. So we stepped into this, which made our code execute here. It's still paused here because we're still stepped into it. And we can continue stepping into this if we wanted to, and it'll just go line by line. Or we could run it, and then we'd see everything. So when we run it again, we are at this, right? So we're at cn.get. So nothing has stopped here because we didn't hit this breakpoint yet. We're currently there. And then we say, press enter to continue, hit the last breakpoint. At this point, the application is already ended, so we don't have access to anything. And then we can just continue to end the application. So those are breakpoints of stepping into, which is allowing me to see the state of my application as I go through it. Now we're going to continue talking about breakpoints in the future, but right now we're just running this application straight up and down, right? Like the way this application is being run is we are starting here and we are ending here, and that's the whole application. That will not be the case come Wednesday or Friday, because we're going to be jumping around doing multiple things, right? But as we are right now, that is what we have. Any questions about that so far? Cool. Good. Hold on, something broke my do not disturb and it's not allowed to do that, so let me see what that is. Hold on. I got an email that I don't think needs to go to me, but if it does need to go to me, I need to see. Well, I can't open it, so maybe it didn't go to me. Okay, good. It's not my problem then. All right. F11 does not fix a bug. In fact, there are no bugs here right now. F11 allows us an opportunity to identify where a bug may potentially be, right? Nothing happens in code automatically unless we tell it to happen mostly. The compiler does what we tell it to do, or what it thinks is the best thing that we think might be the thing that it wants us to do, which, 50-50 there. But yeah, if there was a bug here, for example, if I made a variable called name, and I made a variable called string username, right? So if I did a variable called name assigning the value to username instead of name. And then out here, I'm outputting name. When I run my application right now, right? No breakpoints. I would say, okay, what's your name? I'd say Doug. And it would say, hello. And I'd say, but wait a minute. I totally have a variable called name. I prompted them for their name. I know I'm totally storing the variable in the variable here. Where's the problem? And if I couldn't figure out where the problem was because my application is more complex, or there's like stuff in local files and stuff, the problem. I'm going to put a breakpoint before I prompt them and a breakpoint after I prompt them. And then I'll run it and check it. So here I can see I have a divider and all this stuff, yada, yada, yada. I kind of put that in a random place, so it's not exactly great, but that's fine. So I'll run it. Now I see this, we'll press enter. I'm going to say Doug. And it's going to say, okay, here we have name, and name is empty to an equal string, an empty string. And I'll say, why is name empty to an equal string? What happened? Then I'll go back and I'll check between here and here and say, okay, well, here I'm using username, and here I'm using name, so I can identify, okay, up here, I don't want to be using username. I actually want to get rid of username. It's not useful for me, and just change this to name. And there you go. So that's an example of how breakpoints might help me fix this. It's hard for me to intentionally code bugs, but don't you worry, I will code in bugs unintentionally and have to figure stuff out. I will have to do debugging during this class. As much as this is just like the basics, computer science programming 101, I will mess up. I'm an imperfect creature, I am a human being, right? All right, any questions about this? All right. Now, even though it's not necessarily useful for our Pokemon stuff, we will, for now, take all of this stuff, comment it out by hitting Control K and Control C, and we will visualize some of those conversions just for the sake of having stuff that's directly necessary. So I'm going to come here, I'm going to say stdc out. What is your age? Colon space. I'm going to say std string age is equal to an empty string. And let's just see if even this will work. We're going to say stdc out. Well, you do get line stdc in, and then age. I want to see if this will even let me do this. You are about plus age times 365 days old. Let's see if that. I'm just going to build it. See if it'll let me do that. No, it already doesn't allow me to do that. It already says binary this string does not define this operator or a conversion to a type acceptable predefined to the predefined operator. Predefined meaning because I can overload the operator and change it, and the type multiplication is not usable for the way that multiplication is being used right now, and that's because this is an age. So there's a few different things I can do here. The easiest one would probably be to do std s2i right in here. Now this is an integer, so now we know this is an integer because I'm using s2i to convert it. However, we now have another error. This error says expression must be an integral constant or an unscoped enum type. Now, I don't know what that second one is. I mean, I do, but you guys don't know what that second one is. That first one gives us a hint of what the problem is here. It says the expression must be an integral constant. So, or no, it doesn't say constant, just integral. So an integral sounds like an integer, and that's exactly what it's saying here. It's saying this bit of code right here, this string, must be an integer. Anybody know why it might say this needs to be an integer? Why would it say that? Yeah.
age
you're
is
working down that right
string.
track. What's up?
Age should
Yeah.
be a string.
It's because the addition operator. Because this is now an integral, so it's expecting this to be an integral. So this isn't going to work either, right? Because now everything, we fixed the fact that it was an integer, that this wasn't an integer, so we couldn't do math with it. So now we can do math with it, but now we're trying to combine an integer with a string. Now, aside, asterisks. Some languages, and by some languages I mean literally every other language under the sun, would do what's known as a automatic, I'm blanking on the word, but it would automatically elevate anything else to a string. So for example, if I were to add a number to a string, it would automatically increase this to a string. C++ is not any other language. So C++ is going to say, hey, you're using an addition operator, and you're trying to add a string to a integer. This ain't gonna work. Okay, so let's just do devil's advocate and get rid of that. So that'll resolve that problem. So what is this gonna do? And honestly, I have no clue. I have no idea what it's gonna do. So I'm gonna try to build it. And it says it's gonna work. So let's try it. I am 65. We don't have it. We don't have a thing. Well, no, we don't. It didn't do anything. Actually, it did nothing at all. It didn't even try. It didn't crash. It didn't do anything. It just didn't work. Cool. Congratulations. You've just created a logic error out of a syntax error. You know what's up? That would probably break because string to integer results in an integer. So if you're trying to assign an integer to a string, I don't think that would work. I mean, let's try it. Let's walk through it, right? Let's see. So this right here, we know is causing us a problem, right? This is causing us a problem one way or another. Let's try your way. So let's redefine age as this, and then replace this with age. That is not giving me an error. Rebuild it. All right. Let's put a breakpoint here. Let's see what actually happens. Actually, I'm going to put a breakpoint here and here. So first of all, we're going to hit this breakpoint. We did not hit a breakpoint. Oh, because we hit the prompt first. Okay, so we hit the prompt. I'm going to say my age is 65. 65. Enter. We have now hit the breakpoint. Age is equal to 65 as a string in quotes. So now we're going to run it. And now, aha! I see exactly what happened. What's up? Yeah, it did ASCII value. So what happened is it took the value of 365, or took the value of age, which is 65, multiplied it by 365, and then converted it to a char. So the char with the integer value of 65 times 365. So if we were to expand this, we would see this is the available character. So it converted it to negative 83, which equals out to a minus sign. So it did an implicit conversion here. Yeah, that's you.
And so when you correct it, it age equals this, and then do another string. You can say, like, we're going to use age later for 65. We're going to use age later.
Anytime that we try to assign an integer value to a string without converting it at all, if we just implicitly let it do its thing, it's going to get a similar result to this.
So it's always going to convert it to a char.
Yeah, it's always going to try to do an implicit conversion because that's the path of least resistance. Most languages and some other compilers would just break. This should break. By all accounts, this should break. This is like modern conveniences that they've added to this version of C++, which is making it more confusing than it needs to be. This should probably just break. This should say we can't do an implicit conversion, but it instead is doing an implicit conversion. And this is why I said previously we shouldn't leave anything up to chance, right? We should do everything intentional, because otherwise we're getting weird shit like this, which doesn't make any sense. So okay, we've identified that this is a solution. So let's try something else. Since we can't do that, we're going to say int new age or int age or number age is equal to this. And then over here, we're going to say number age. Again, I don't know what's, okay, so now we run into the same problem. So now we have that. So we need to do one more thing, and that is convert this integer from a integer back into a string so we can plop it in the middle of a string. Now, there are two separate ways we can do this. The one way I can do this is I can insert the integer into the string, or into the stream, using the insertion operator. And guess what? That will automatically graduate it to a string. Why? I don't know, man. This is where we are. So this will automatically graduate it to a string. Again, this is happening automatically. We probably don't want to do that. So what we probably want to do is we want to explicitly convert this. This is going to be a thing that we have not discussed, but you guys are required to do as part of your lab too. I typically make you guys research this on your own, but we can do it ourselves here. For every kind of number that is available, let's just actually see. Let's see. Let's come here. Let's go to Google. This is your number one skill. I closed the wrong thing. This is your number one skill as a developer, by the way, is how to use Google. So I'm going to come here, how to convert a integer to a string in C++. See this right here? This is an AI answer. I'm not going to read this because this could be wrong. I'm going to read Stack Overflow. Stack Overflow says, I'm trying to convert this to a string. How can I do that? I don't understand what this stuff means. What is the answer? This guy says C++ includes std, s2i, which converts from numbers, and std to string.
If you read other people's work, they tell you that it's plagiarism. So, how would a student that's just starting school know that it's acceptable to listen to what some random person on the internet has just said?
So, to string does to string. So what we can do is we can say, okay, what is this? This guy linked to documentation. That's a good answer. So this is a bunch of different versions of to string that take in integer values and return out strings. So it says convert a numeric value to an std string. So that's probably what I want to do. So just like std to s2i does string to an int, std to string does an int to a string. So now when I run this, and I say I'm 65, why doesn't my 5 work? It says I'm about 23,725 years old. So, to back up, here's what we did. We took a string, we prompted the user using stdcout, and we stored the age as a string. We then used s2i to convert that string into an integer so we can do math with it. And then stored it in age, or number age, which is an int. Then if we wanted to concatenate that int with a string, we needed to convert it back to a string using the toString method and passing in the age. Yep, as an integer. So we can, let's do this. Let's put a breakpoint here, and then we'll just step into each line. So here we see age doesn't exist yet. Step into it. Age is an empty string. Step into that line. I'm now getting prompted. Step into this line, and I can actually enter in data. Which is complete. 65. Now we are here, and you can see age is now equal to 65 as a string. Age number exists as an age number, right? So this means that this is the default initialization. We don't have a number yet. We can step into it now, and now we can see it stores that value like this, and then eventually we're just going to write that out as a string. Done. Now there's the debugging tools. All right, any questions about this? All right. So, got another set of slides to look at real quick. Because lab 2 is going to start a pattern that is going to be repeated throughout all of your assignments. So we're going to knock this out right now. So, there are 8 labs in this class. By now, you guys should have seen lab 1. In lab 1, you guys had to create your own project. For every single other project in this class, you will be provided with, or for every single lab in this class, you will be provided a project. This project will do a number of things, like give you automatic feedback, as well as provide randomized data to test them against your logic. Here's the process. You guys are going to see a lab. It's going to be in a zip file. You should right-click, save that zip file somewhere to your computer. I don't recommend putting it in your downloads. I do recommend saving it directly to the folder that you created. Ignore that. Just ignore. I have more hard drives now. I have a network attached storage now. So make a new folder for your projects, put it in there, and then right-click Extract All. That'll bring up a dialog that says, do you want to extract it to this folder? You're going to say yes, and then it'll open up that folder. So you will have a folder that looks like this. Inside of this folder, you're going to see more folders, but you're also going to see this file. If you don't have your file extension shown, it won't show that .sln, but it will still say the type of a Visual Studio solution, right? You must open your project using this file. This file opens up the entire project. If you go into this folder and open up an H file or a CPP file directly, that just opens up the one file. It doesn't open up the entire project, and your project needs all of the folders and files to run. So, you get that solution file, and it'll open up Visual Studio. It may look like this when you open up Visual Studio. Most of the labs won't look like this, but the debugging exercise absolutely will. This does not mean that the application is broken. This means that it opened up the project, but it didn't open up a specific file in the project. When you create a new project, it by default opens up the default CPP file. Opening up a new project, opening up an existing project doesn't do that. So you will need to open up your Solution Explorer, locate work.h, and open that if you don't see anything. Inside of that file, you're going to see a series of tests. These are basically worksheets. The tests will look like this. There'll be a block quote, and the block quote, or the block comment will have instructions on how to complete the test. So this says, given an integer parameter number, return the given value multiplied by 4. An example input is 5, and an expected output is 20. So if you are given 5, what I expect to see out is 20. This is the parameter. We'll talk more about this in detail tomorrow, but this is the variable that will be assigned that randomized value. So number is going to be equal to some random number between 0 and 10. So in this case, if number is equal to 5, I want 20 out. This value that here, that follows the return, is the value that is given as a result of this method. So if I were to run this right now, I'm going to see output that looks like this. This says input was 6, expected output was 24, and the received output was 0, which means number was equal to 6, I expected to see 24, but what I got was 0. So these are all the randomized values you were given. This is the expected value that I want to see out based on the given value of the instructions. And right now, I'm only getting 0 because all this method ever does is return 0. Does that make sense? Any questions about this so far? Cool. So, 2 key things about this method. Right now, it has an int return type. Remember how I said we're going to define this method and it's going to have some kind of value or type, just like we define variables? That's what this is right here. This means every single time this method runs, it should result in an integer value. And right now, it's resulting in an integer value of 0 every time it runs. Nothing other than 0 ever comes out of here. So the first thing I want to do when I'm going through one of these tests is I'm going to identify what type of variable or what type of value I want out, and I'm going to make a variable of that type. So now I said, okay, instead of literally returning 0 every time, I'm going to make a variable that I'm going to store the results in, and by default, I'm going to store 0. Then I'm going to change the return to return the value stored in result, which means, for those of you keeping track, if I were to run this right now, it would still be 0 all the way across the board because I never changed the value of result. But now I have a box that I can change the value out, the output value of. Does that make sense? Cool. So now, it's a good time for me to put some comments, initialize the placeholder result, return the result, and then between here and here, all I need to do is basically write out the instructions. Because the instructions will more or less tell you what you need to do. So, in this particular case, I need to set results to number multiplied by 4. Because that's what the instructions say, right? So, I'll just do that. Result is equal to number multiplied by 4. And now when I run this, we're going to see everything passes. Bingo bongo. So you will repeat this for about 10 times for each lap. So you need about 10 10s for each lap. Most of your solutions should look something similar to this. All right. Now we're done. So the first thing we need to do is we need to close the project, because otherwise we can't, it's still open, we can't interact with it. And then we're going to go to the folder where our project is. We're going to locate the solution file. Once we locate the solution file, we're going to go to the folder above that. So the folder that the solution file is inside of. You can do that by clicking here on this breadcrumb or pressing this up arrow. So this folder, right, this one right here, is the folder that contains my solution file. This is the folder I'm going to zip up. All right, right-click that, compress that to a zip file. That's what you upload to FSO. When you upload it to FSO, you should download it down, extract it, make sure you can run it. Because if you don't, you can't run it, then I can't run it. When you try to close Visual Studio, Christopher, it's going to say, do you want to save all changes? You have it. I obsessively press Control S all the time. Like every time I do a line of code, I press Control S. So, but if you close your application, if you close Visual Studio, it'll ask if you want to save everything, and you can do that. You can also do Control Shift S, and Control Shift S will actually save all files. If we start with 0 because 0 is a predictable default, we could have started it with 20 since we override the value that's stored in it no matter what, right? When it runs, it overrides that value. So that initial value isn't really important. I just set it at 0 because that means that if I'm debugging something and I see 0, then I know that something's wrong. Like sometimes people will use -1, right? Because that's another easy thing to see. So if you default to -1, and you're like, oh, it's -1, that's not right, right? Because you look at that, and that's a good default value. So if 0 is like a potential value that you expect to see, then using the negative value might be easier to identify that something hasn't changed. But when you're dealing with a larger application, it's good to have defaults, predictable defaults set to make it easier to recognize if those are changing when they need to change. If that makes sense. All right. So late submissions. We have a late work policy that will allow you to upload a project up to 48 hours late for a 10-point deduction. If you want an extension, we will generally give you extensions if we know so before the due date. That is, don't message me on Monday and ask for an extension. Message me at least on Sunday. Probably though, if you really want an extension, message me on Friday, because I'll see it. I might not be looking at my emails all the time during the weekend. So if you need an extension, just let us know before the due date. So if you don't get an extension, like I said, the assignment will remain open for 2 days. After that, it will automatically be graded to 0. However, practicals, so this is the policy for the entire program. So exams, practicals, and quizzes, but in this particular class, practicals, you cannot accept late work. So they are due when they are due. No late work, no extensions. And most importantly, I cannot give any extensions in week 4 because I have a grading deadline, and anything that has been graded cannot be resubmitted. So if I have graded something, that is it. There's exceptions to this, and that is if you turn in a project incorrectly, what I will generally do, this is students in my sections, does not involve Ullman or Maxwell or Carl. What I will generally do is I will give you a 1-day extension from the day that I see it, and I'm going to grade it as 0. That way you can come back and resubmit it, and I'll come back and regrade it. But that's the only circumstance. If your project just like, you just upload a single file, but if you just upload the solution file, that's not your whole project, and I can't open it, I will generally give you some more time to do it. But most often, if I've graded something, that is your grade. That is also true if you violate the external resource policy. If you use like size T or static cast, and I say, hey man, you get a 0, you do not get to take that project back and then fix it and then resubmit it. You did what you did. Zero tolerance policy. All right? Any questions about that? All right. So let's take a look at lab 2. So I'm going to go to FSO, which is going to be here. Go to FSO. On FSO, I'm going to scroll down to here, and I'm going to go to preview, and I'm going to go to week 1. I'm going to scroll down to lab 2. Lab 2 has some instructions, has a video showing you how it should work. If you want an explanation on how the detailed explanation on how the debugging assignment should work, I recommend watching this, because Amara will explain how that works. Some objectives, yada, yada, yada. Resources, here. There are 2 files in here. The debugging exercise is test 1 and 2, and tests 3 through 10 will be in the Lab 2 project. I will need both of these projects back. This is also explained in the debugging assignment. This is those slides I just showed you, so you don't need to watch that. There are FAQs in the FAQ channel, and there's 2 different videos on how to extract files. Keep an eye on that. I come here, I'm going to save this to my current folder. Then, I'm going to click here and open up the folder and save it to. I am not going to double click this folder and try to open a solution. This will not work. This will result in an error. If I try to do this right now, it's going to say one or more projects in the solution cannot be loaded. See the output window for details. And if I press OK, it's going to pop up the output window. And if we look at it, we should see it's trying to open the solution from a temporary file. It's because we tried to open it from this, because it took the solution file only, put it into a temporary file, couldn't find the other project files. That's not going to work. We're going to close this, come back here, and then here, we're going to right click, extract all to a folder. Now this folder is the folder we're looking for. So we have 2 folders, conversions and debugging. I'm going to open up the conversions by opening up the solution. So this should automatically open up that student work file. So here we go. And here are your tests. So, use the S2I method to convert the string parameter into an integer. So you're going to be given some type of input as a string, and you're going to get out some type of integer. For example, -5 in quotes. Expected output, -5 as an integer. Here's your input.
Short answer, no. State_style is not a method. It's a free function in the C++ standard library namespace did that converts a string to a double. What it is: header, string, signature, simplified. You can see the code in our conversation history. There are overloads for CW strings, C-style strings, etc. Basic anatomy, how you use it. You can see the code in our conversation history. Behavior. Parses an initial floating point number from the string. Post option with non-number receives the index of the first char after the parse number. Exceptions. Instead, invalid argument, no conversion could be performed, e.g. ABC. Static out of range, value can't fit in a double. Related conversions. Integers. Stole, instead stole. Floats, long doubles. As stole. Non-throwing and fast alternative for raw buffers. Step from chars, then char. Terminology note. In C++, method usually means a member function of a class struct. As style is a namespace level function, a free function, not a member of a class.
By default, this will return that negative 8 million number. So again, identify what the placeholder, what the variable is. This is an int. So we're going to say int result is equal to 0. Return result, and then set result equal to input sent to the S2I. The end. Now, test 4. Use std to convert a string to a double. Test 5. Use s2f to convert a string to a float. Test 6. Use s2ul to convert an unsigned long integer into an unsigned long integer. Use s2ll to convert an unsigned long into a unsigned long. Test 8. Use toString to convert an integer to a string. And then test 9 and 10. Use explicit casting to convert the double parameter to a float, and use explicit casting to convert a float to an int. So all stuff that we have discussed today. Are there any questions about any of this so far?
No. Thank you for doing your job.
I'll close that. I don't need to save any of that. Now I'm going to go up here to the debug assignment. The debug assignment's a little different. There's a Word document associated with it, and there is a solution here.
I'm spent.
When you open up the debug assignment, you gotta come up here, go here, open up debugging.exercise.cpp. It's going to ship with errors. There are 5 errors in here. If I try to rebuild this application, we'll see them all on the error list. We should, but we don't. That's very cool. Visual Studio is weird sometimes. There we go. So those are our errors. Spoiler alert, all the errors are typos. That's it. So you just gotta fix a bunch of syntax errors. You can see identifier undefined, identifier undefined, identifier undefined. How you fix these typos is up to you. What your goal is at the end of the day is to just make this work. Following that, there's going to be a series of instructions in this Word document. These instructions will require you to put breakpoints on specific lines, right? And write down what the result of that breakpoint is. So when you stop at a particular breakpoint, what is the console, or what does it show up in the panel? Like, what is the value of this variable? What variables are there? What are their values? So this is going to get you to place multiple breakpoints and read out the values of those breakpoints, and just fill this out based on those instructions. The support class, the support.cpp, you generally don't need to worry about, but it's just going to be more code, and it's just code that generates some random values and does all that stuff. There's no errors here, you don't need to touch it. You can see it makes a random value, it reverses a string, it has an age, stuff like that. So this is just helpful stuff. There's going to be other folders, other files and folders included in your projects. Don't touch them. If it says there's an error in there, I promise there's not. And the error is in your code, not in mine. That code is going to be all the code that generates the random output, as well as generates the random output, also compares the output to an expected output and gives you a result, right? And writes to files and does all kinds of reads and writes from files and does all kinds of crazy stuff. Don't look at those files. It's just going to confuse you. If it says there's something broken in there, don't touch it. If you touch those things, it's going to break everything. Any questions about any of that? Alright, that is all I have for you guys today. If you have any questions following this, just make sure to reach out via FSO, or not FSO, on Discord. I actually will not be here on Friday because I'm actually not supposed to be here at all this month, so I am scheduled to do graduation on Friday. So Carl will be here for Friday. You guys will like Carl, he's just fine. And I will see you guys again on Monday, right? So if you need me specifically, just reach out to me at FSO or something like that. Otherwise, Carl will be here for all you guys on Friday. Thank you guys all for coming out today, and I will see you again on Monday, and Carl will see you again on Friday. See you later.
I'm going back to bed. I need to sleep. I gotta get to work at 4 o'clock in the morning. Oh, I gotta wake up to get ready for work by 4. I could be at work at 5.